Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Ah. Okay, so basically today I'll just be taking you through how to use your calculator to answer your question one statistic question. So which we do know that with your statistics, you should be collecting marks there. So this is the question that you have right here. So your question one, it's for 10 marks, right? So we're just gonna be using this one and then going through it. Okay, so this is how you're gonna do it. You're gonna obviously grab your calculator. And then with this one, this is a 2-variable data. So what you want to do is you want to come here, right? So mode setup, and then you want to press where it says stats. So that would be your 3, right? And then if it was a 1-variable data, you just press 1 variable, but then note that we know that this is a 2-variable data, and then which aligns with the equation of the least square regression. So we need to say 2 here, right? A plus bx, then 2. And then as you can see, it gives the column for x and also y. So where there is x, we are being told here that it's weight in kg. So these are the values that you need to put in on your x column. And then the number of push-ups per minute is y. These are the values that we need to put in our y column. So carefully, you just have to punch all those values there. So you have your 34, and then you're going to press equal to enter that value, and then 32 equal to, and then 40 equal to. So you just have to be careful. Make sure that you punch in your values correctly, because one mistake here, you can just kiss those marks goodbye. So 33 followed by 28. So what could actually help you is to tick off those values as you are putting them there, right? So as you are putting those values there, you can actually tick them off so that you remember that you have already put in the value there. So there we go. Just gonna indicate like this. Oh my God, what's going on? Okay. Then I have put in this one, that one, this one, and that one. So followed by what? 27. So I'm gonna say 27 here. And then again, enter. And then now I've marked in that one. I have 55, right? And then I have a 39. And then I have 44. Then I have a 30. And then followed by 57. Followed by 28. So this is a very boring task, but then you need to do it, right? So you have your 32 here, and then you also have 31. Right, so all 15 are there. All 15 are there. Then what you need to do is confirm. Before you can do anything, confirm again if those values are correct. So we have 34, 32, 40, 27, 33, 28, 27, 55, 39, 44, 30, 57, 28, 32, and then 31. So we are fine with that one, right? Then now let's come over to the y values. We have first the 26, and then followed by 21, 21, then followed by what? 6. And then we have a 20. Then we have a 16. Whoa, 20. Let's put in 20. Enter 20. And then 16. enter 16, and then we have a 26, so enter 26, then we have 23, enter 23, and then followed by a 7, enter, followed by 18, then 14, then 17, then we have an 8, we have 28, we have a 25, then lastly we have 20 again, right? So again, let's confirm if everything is correct. So we have 26, 21, 6, 20, 16, 26, 23, 7, 18, 14, 17, 8, 28, 25, then 20. Right, so we are fine. Right, now all you are going to do right now, everything is now punched into your calculator. Just press on, then your calculator has already saved that for you. As you can see, calculator is at stats. Then 1.1 says determine the equation of the least square regression line for the data. Now, the least square regression line is in the form of what? It's in the form of y is equals to a plus bx, right? So that means in this case, you need to find the value of a, find the value of b. How do you get those values there? So to get those values, this is what you need to do, right? So you're going to come here, your calculator, this time you press shift and then 1, so leading you to stats. So the variables that you are looking for are here on regression 5. So this is the a that you are looking for. Then you're going to say equal. So your a is equals to what? 39.46. You're going to round it to 2 decimal places. Then again, you're going to come over here. And then again, shift 1. And then regression. Now you're going to punch in your b value. So that's negative 0.59. Then you're going to write that one and say b is equals to negative 0.59. So your equation in that format will now be what? 39.46 plus, or because it's a negative, so we're going to say minus 0.59 and then x. Now it's up to you. You can then rearrange it and write it as negative 59x and then plus 39.46, right? So if you then want to indicate it like that, but then even leaving it like that is still correct. So y is equals to negative 0.59x and then plus the 39.46. When you're writing it like this, you are simply writing it in the format of a straight line because your least square regression line is actually a straight line. This is the line that we are talking about. Now, okay, that would be your 1.1. Now for your 1.2, they say write down the correlation coefficient. What is the correlation coefficient? Simply going to check it here. This is shift 1, and then again on regression, your correlation coefficient is actually this small letter r here. So you're going to punch in there, and then it gives you what? Negative 0.797, which is negative 0.80, rounded off to 2 decimal places. So for 1.2, we're going to say our r is actually negative 0.8, right? Or 80. So that's it. That's it. And then it's just a mark for that one. Now 1.3, they say the coach uses the least square regression line to set the target for the minimum number of push-ups by each team member, meant to say, according to their weight. Predict the number of push-ups that a member of the team who weighs 29 kg should do to meet the target, right? So we are using the least square regression line for that one. Okay, so let's go now. So that means all we have to do is for 1.3, we already have the least square regression line. So we're just going to substitute into it. But then the 29 kg here speaks for x, right? Remember, the kgs are given as your x. So that means in your least square regression line where there is x, you need to actually substitute in that value there. Right, so this is how I'm going to do it. I'm going to say y is equals to 39.49 minus 0.59. And where there is x, I'm going to put what? That 29 that I'm given there, 29. Then obviously you simply just have to punch all of that into your calculator, Then let's do it. Let's do it. So we're going to say 39.46 minus 0.59. Wait, 0.59 bracket 29, close bracket, then equal to. There we go. It gives us 22.35, right? So that's 22.35. Hallelujah. Right. So that's it. Now 1.4. So this was your 1.3. 1.3. In 1.4, they say write down the mean number of push-ups for the given date. The mean number of push-ups, right? Meaning y. Now, note that mean can be indicated as x bar and also can be indicated as y bar. When it's x bar, it means it's the mean of the x values. So this is the mean of x values, right? And then y bar, this is also the mean. This is the mean of what? Y values. Now you simply just have to check that whatever that you are given there, is it representing the x values or the y values? Now the mean number of push-ups are where? On the y values. So that means on this one, we are not looking for x bar, we are looking for y bar. Right, so that is a very common mistake for learners to just assume that mean is only just the x bar. Y bar is also the mean. Shift and then 1, and then we go to what? Again, we're going to go to regression, and then which one are we? No, not this one. So I think we should go to, so again, it's shift 1. Wait, shift 1, yes. And then we're going to go to variables. Yes, we find that on variables. Then which one are we going to select? Definitely not this one, because they're not looking for the mean of the weight. They're looking for the mean of the number of push-ups. So that means we go with a y bar, which is on 5. So we're going to say 5, and then is equals to what? So our answer for 1.4, we are going to say y bar is equals to what? 18.33, right? And that's it. Okay, very nice. Then let's scroll down. So what are they saying now? They're saying the players trained hard. So let me just erase this. Hopefully we've noted all of that already. If not, you can just rewind the video. Okay, so we have 1.5. It says the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. How does the increase in the number of push-ups influence the standard deviation of the date? Right. Now, we know that the standard deviation does not get affected, right, by simply increasing those, because simply what you are doing here, if you're going to be adding 5 push-ups to everyone here, right? If you're going to be adding 5 push-ups to everyone, the standard deviation will still remain the same, because you'd have added the same number throughout, right? So here we are just supposed to say the increase in the number of push-ups will have no influence. So there is no influence. No influence, meaning the standard deviation remains the same. Remains the same. So the change that happened here, or the increase that happened, happens with everyone that's involved in there. Okay, now we have 1.6. It says at the beginning of the season, the coach used the least square regression line as the minimum target. So let's highlight that. Use the least square regression line as the minimum target for a player to aim for. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. So for that, we're going to look at the least performing player there, right? So the least performing player is this one, the outlier here. So at 40, with a weight of 40 kg and has only done 6 push-ups, right? So on a weight of 40 kg, this learner has only done 6 push-ups. Now we want to check what is the minimum that this player should increase in the push-ups to meet the minimum requirement. So still on the same line there, if we can do this, still on the same line, we would stretch it out. Remember, we are using this one as the least square regression line as our minimum, right? So that's what we should aim for. So a learner here should aim to increase and touch the what? The least square regression line there. So meaning that someone of 40 kg would be expected to at least do how many push-ups? 16 push-ups. Now from the 6 that he did to the 16 that is expected to do, what's the minimum number of push-ups should he do on top of the 6 there? So basically we would have to say 16 minus 6, and then this will give us what? 10 push-ups, right? 10 push-ups. So that it lands at what? 40:16. So there has to be a minimum of 10 push-ups that the player does or the team member does, so that they meet at least the minimum requirement of the least square regression line there. Okay, so that's basically how you were supposed to answer your 1.6 right there. Okay, nice one. So I hope you have seen how to use the calculator to answer those questions on statistics. Keep on practicing and make sure that you bag those marks. Most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.